Hello and welcome to today's webinar. Today we are going to talk about Universal Plant Viewer and the new export module. My name is Wolf Volkmann. I'm Senior Consultant and responsible for innovation technologies at CI Experts. And yeah, I will guide you through the webinar today. So before we jump into the export module, I would like to share the agenda with you for today. So first we are going to talk about why would we like to export data from within Universal Plant Viewer. Then we will have a look at the use cases like VR, AR applications, re-importing data to CAD systems, 3D printing obviously is also a topic. We are also going to look into the formats that we do support in the export module, which are OBJ, FBX, and Microstation DGN. I will also explain how to use the export module within Universal Plant Viewer. Then we will see a live demonstration, and afterwards we will have some time for questions and answers. Okay, so let's start with why export. So as you might know, Universal Plant Viewer does support various 3D model formats. So some of you might remember this part of a slide here where we have an overview over the different adapters that we offer for Universal Plant Viewer. So those are only the 3D adapters, obviously, but I want to explain them for a moment. So we have one adapter called Review Adapter. This one is able to convert your Smart Plant review data. So this means view files and SVF sessions. We do have also a support for PDS in here, so DRI, DGN, and DRV files can also be converted using Review Adapter. For E3D or PDMS, we do have this PDMS adapter. This one basically consumes RVM and ATT files. But if you rather would like to go for Navisworks, there is also the adapter for Autodesk Navisworks. So this one can basically read any kind of data that can be read by Navisworks. For BIM models, we do have a separate adapter, which is the IFC adapter, which can read the IFC files natively rather than using Navisworks. And the last one here, the laser scan adapter. This adapter is basically consuming your laser scan or point cloud data and also does an automatic meshing of this data. So we will see this later in the demo. However, I also want to mention that the laser scan adapter can also be used to bring in any kind of OBJ data. This could be whatever kind of data, but it also supports textured OBJs. So if you want to bring in your textured graphics, this is also possible using the laser scan adapter. And all of these data formats that we see here, they can be combined in Universal Plant Viewer. And therefore, obviously, as you have all your data combined in one viewer, this is the best position to do an export for feeding the data to any other application. As already mentioned, we do the automatic mesh creation for point cloud data, and those meshes that have been produced by the laser scan adapter can also be exported, as we will see later on. Some of you also might know our sketching, which is a conceptual design tool where you can place basic objects, or you can even have a catalog of objects that you want to use. Of course, those sketches or conceptual designs can also be exported from within Universal Plant Viewer. The export module was called VR export module earlier, so we did change the name because now this module is not only for VR anymore, as it has more use cases that we will see in a moment. So if some of you might already have the VR export module license, this will also automatically be export license in the future. Okay, so let's have a look at the use cases for a moment. VR and AR applications. As you know, Universal Plant Viewer currently is not capable of doing VR and or virtual reality and augmented reality. However, there are good products for those use cases. but those products require the data that needs to be shown, obviously. So therefore, Universal Plant Viewer can be used to feed those applications. And what is essential for this use case? Obviously, it's the attributes and the original coordinates of the objects. Especially if you use augmented reality, like with a HoloLens, and you want to go out into the field and want to see the pump in the exact right location, then obviously you need the original coordinates. And another thing here is that we can also export the laser scan meshes. So here at CA Experts, we have done a lot of tests where we could walk through the laser scans in a virtual reality application where the laser scan meshes have been exported out of Universal Plant Viewer. Another use case, or maybe one of the main use cases here, is the reimport to any CAD system. So again, Universal Plant Viewer allows to combine all the data in one viewer, and then you can basically export this data in a combined way and import it back to your authoring system. And here again, attributes and original coordinates are pretty essential, because with the original coordinates, you can just add the file, whatever format you are using, to your authoring system, and the items will be shown at the exact correct location. And once you select an item, you will also see the attribute or property information of this item. The last use case that I have here in my slides is 3D printing. So this becomes more and more a topic these days. Those 3D printers obviously also need the data in order to print it. They mostly work with primitive graphic formats, so this means something like OBJ or STL, and Universal Plant Viewer could also be used for this. Okay, so now let's have a look at the formats that we do support in the export module. There are 3 formats supported currently. This is the Wavefront OBJ, the FBX, and the Microstation DGN format. I will go into a little more detail of each format for a moment, and then afterwards we will go to the live demonstration. So OBJ is a file format which is called Wavefront OBJ. It's on the market since 1989. It does support to have material and texture files, and it's a very neutral format. And this is already one of the main advantages here. It's the most common format. It can be consumed by almost any 3D software application, and it does support textures. But if there are advantages, obviously there are also disadvantages. So the big problem about OBJ is that there is no real attribute support or property support, even so that objects can have a name, but there's no additional properties like having a pipeline system or whatever. So this is one of the disadvantages. Another one is the size. This is because OBJ is a ASCII file format, so the files get pretty big pretty fast. And the last disadvantage here is that the format is implemented differently in various software systems. If you have dealt with OBJ before, you might have noticed that in some applications, the y-axis is the up axis, while in other applications, the z-axis is the up axis, and stuff like that. But we have a solution for that I will show you later on. The next format is FBX. The original name of FBX is Filmbox. The format is on the market since 1996, but it was acquired by Autodesk back in 2006, and it's the one Autodesk Exchange format. It's a proprietary format, so this means it's not human readable in most cases, and also, as we will see in the disadvantages later on, there are different versions of it and so on. The advantages of FBX is obviously that it's supported by Autodesk software and also many others. So especially virtual reality and augmented reality applications do support FBX, and This is also the advantage because FBX does support custom attributes or properties. Okay, instead of using OBJ, so you could then use FBX, and this would allow you to also bring your attribute data to the file format. The FBX format can be stored in binary or ASCII format, and it does even support animation, which is not utilized yet from Universal Plant Viewer, but maybe in the future. The disadvantages are that there is a version management. So this means there are almost every year there is a new version of the FBX format, and this can also be a problem when converting the data. And the other disadvantage is that the custom attributes or properties cannot be read by all of the tools. Okay, so we have seen some tools that could not read it, while there are many other tools which can read it. And now we are coming to the last of the three formats, which is Microstation DGN. It's called Microstation Design File. It's available since 1987, invented by Bentley Systems. It's also a proprietary format, and the advantages here is it's the most common CAD format, so it can be consumed by almost any CAD software. It does support primitives, so instead of having a lot of triangles to reflect a tube, for example, you can have a primitive basically, and it also does support attributes. So okay, this is not completely correct. The DGN file does not support the attributes, but the DRV file that you can have with the DGN file, this one can hold the attributes. The disadvantages here are, again, version management, so Microstation version 7 versus version 8, and they are not very compatible to each other. And the other thing is that there is no real support for textures. Okay, so having said enough for the formats, now let's have a look how to use the export module. So in the Universal Plant Viewer, as you will see in the demo in a few moments, there in the file menu, there is a button which looks like this one here, and this is the button which will bring you to the export dialog. The dialog basically looks like this, what we can see here. Here you can choose your file extension from a drop-down. I did bring a screenshot here for each file format to show you the different options that are available. So you can see, for example, for OBJ, there is an option to swap the Y and the Z axis. And obviously this is because of the different implementation in various systems. And there is another option, include model offset, which would basically allow you to have the objects at their original coordinates like they are in Universal Plant Viewer. If this is checked, it will be the original coordinates. If this is not checked, this option here, then the graphic will be in the center of the OBJ file. For FBX, it's almost the same, but there is one more option here to include the attributes. And for Microstation DGN, we also do have an option for attributes and for the model offset. Okay, and now let's have a look at the live demo. So I've already opened Universal Plant Viewer here on my machine. I can now navigate inside the Universal Plant Viewer as I'm used to. And what I will do for the demonstration is I will pick this vessel over here, which is our D-240. And as you might notice, we have used our SDK plugin graphics to bring in additional labels into the graphic, so we can also see the tag name written onto the equipment. What I will do now is I will use our navigation structure here on the top to select the vessel with all its nozzles. So we can see it's now 9 objects within UPV that have been selected. And now we can go to the export module. Again, just open the file management. Here there is the export button, and then you will get to the screen where you can specify how you would like to export the data. I'm showing you here the newest beta version of Universal Plant Viewer. So in this version, there is a new option available, which is called Target, which I will explain in a moment. And this will be available with the next release coming up this month. So let's start from the top. So we have the file extension that we can choose. So for example, I can say I would like to export this as an FBX. Then next, the target. This is basically what I would like to export. I can export everything in the session by selecting all. I can only export everything that's visible at the moment, and this visible will also consider a volume clipping that you might have applied. Or I can use selected, which by the way is the behavior that the previous version had. Or I can use enabled, where all the things that are currently enabled from the project tree, so from the navigation structure, will be exported. In my case, obviously, I will use selected to only have this vessel with the nozzles. And now we can see the options again. Here there is the include attributes button that I will check. There is another button here which is also new. It's called include links. This allows me to add the links that we can have in Universal Plant Viewer. You can see them over here. They will also be brought into the FBX file as an attribute. Okay, so as you might know, Universal Plant Viewer allows you to define links from your model items to, let's say, your SharePoint, to your document management system, or any other application. And those links can also be included into the export using this option here. And again, we do have the option for the include model offset, and we do have an option here to include the textures. I won't check those because, first of all, my object does not have textures, and for demonstration purpose, I will not include the model offset because I want to have it centered. Now I can press save. It will now ask me where I would like to store my file. So I will just enter a file name here. You can see the extension is FBX, press save, and that's it. So now what we can do is I will open up my Blender, which is my preferred tool for importing graphic objects. From here, what I will do is I will import FBX data. So I will navigate to the folder where I did store the file. We can see here it is. And here's already the first trick. As I said, the custom properties that are supported by FBX, they are implemented differently in various applications. However, in Blender, you can see there is an option over here to include the custom properties. I have this checked because I want to see the property data. And now what I will do is I will import the FBX, and we can now see that the graphic is here. We can see that even the labels on the additional aspect are in here. And if I select a piece, for example, this nozzle over here, I can go to the custom properties down here in Blender, and I will see all the attributes coming from the Universal Plant Viewer. We can see that there is even the link to bing.com is included in here because I did check the include links option. But I can also select some other part like the vessel itself. Then obviously we will see that there is no nozzle name now. It's really the equipment itself. So what I'm trying to say is all the objects will have their attributes attached, and you can directly see them here. And this does not only work within Blender, just for demonstration purpose. I will also navigate to the folder where I did export the data. I can also just do a double click on the FBX file, which will open up the Windows 3D Viewer, which is a standard application, I think. And you can see that we can also import this here. Okay, yeah, so this is basically how it works. Maybe one thing that I would like to show also is that if I go into the laser scan section over here, maybe let's start over here, I can always do a volume clipping. So let's say I want to export only a certain portion of my laser scans, then I can basically define a clipping volume like this. So you can see we have, So you can see we have now the 4 pumps included in here. And then what I can do is exactly the same like I did before. I can go to the export panel, say I want to export this as FBX. This time I will choose visible in order to have the volume clipping applied. And then what I did check was include textures, include attributes, and I did press the save button. I won't do it now because it takes some time to export the data, but I have prepared here already in Navisworks. So you can see that's the FBX file that we did import back into Navisworks. And now we are not seeing the point cloud, but really the meshes coming from UPV. So this means you can directly see that this works out of the box. But one thing I want to mention here is that even though we do allow you to export the meshes and the textures and everything, you are free to import this to any system that you want, but of course, still the limitations of the target system do apply, okay? So for example, we did some tests of exporting all the meshes and trying to import them again into a soaring system that I don't want to name here. And we did notice that the soaring system was not able to handle all the scan data, okay? So this is something that you still need to keep in mind, even so that we are not working with the point cloud data anymore, but really with the meshes that we created. Okay, so let's maybe do one more example in here. What I will do is I will pick the whole recovery stage in here. So I have just used the navigation structure to pick the whole recovery stage. Then I go to the export dialog, say I want to save this as OBJ. Target is selected. I would like to I will not check any of those options because we don't have textures here. I don't want to have the model offset, and I don't want to swap the axes. And if I do so, I will just call this demo 11. This gives me the OBJ file. And now if I go back to my Blender, I will just do a new file here. Then I can go to import. I say I want to import wavefront. I navigate to my folder where the file is related in. So I have my demo 11 here. And now you can see what I mean. When importing OBJ, you might need to specify the axis you want to use. So in my case, I did not swap the axes. Therefore, I will select set as the up axis. But if I would have checked the option to swap the axes, I would not need to change it here, okay? And now I can import this basically here into my Blender, and you will see we have all the graphics in here, we have the colors in here, we can navigate in here. But of course, as this is now OBJ graphics, it does not include the attribute data. But you can see that even the labels did came across again.